Okay, welcome to day 5, people. This is question. What is this question? 6. Question 6. Cool. And this is another one where we're going to be doing an optimization. So we're going to be differentiating to find the stationary value, and determining whether it's a maximum or a minimum. In this case, it's about the area of that rectangle. And I guess I'm thinking you guys must have rated again because you're still finding it a little bit tricky to get the area that they're after in terms of x. So let's just go through a little bit more slowly, because sometimes I think maybe potentially in the exam, to make it super hard, they wouldn't even scaffold part 1 for you. So it is really important that we know how to do this for ourselves. It's all about trying to find relationships in the situation they're given to you. So first of all, here's a rectangle. It's very exciting. According to this diagram, the point Q is across x and up y. So that means that the width of our rectangle is x and the height of our rectangle is y. So the area in terms of x and y would just be x, y. Of course, that's not what they've got here because they've got the area only in terms of x's. So what we have to do is find an expression that y equals so that we can substitute that in here and make this whole thing only in terms of x. So go back to our diagram, and we've got to find a way to make another equation that uses x's and y's that we can exploit to replace that y value. So we look back here and we see that they've got this line. We've got these two right angle triangles sitting here, one here and one here. And what do they have in common? Well, they have in common the fact that they're on the same line, which means that their slope is the same, so the gradient's the same. So here, for this section here, we know that the gradient is the change in y over the change in x. The change in y is taking one y value and subtracting the other y value. So in this case here, it's going to be 12 minus y. And then the change in x is going to be taking the x value, which is 0, and taking away x. So 0 minus x is just minus x. There. This part here, again, we know it's going to actually have the same value of m. It's going to have the same gradient. So if I go here, what's the change in y this time? Well, it starts at y, it goes down to 0, so y minus 0, so just y. And the change in x is x minus 16, like that. Okay. So that's cool. So now we've got x's and y's, and we know that these two values, whatever these gradients are, they've got to be the same ratio when we work out those fractions there, because it's on the same line. Okay, so the other word for being on the same line is collinear. So if points are collinear, then they'll share the same gradient as well, because they're on the same line. That might be another word that comes up in other exam questions. So what do I do with that? I just basically take those two expressions and make them equal to each other, like that. And what I want to do is do some algebra to this whole thing here. What I want to end up with is down the track somewhere, y equals something. And that something is just going to be in terms of x. Okay, so now it's just a little bit of algebra. What can we do? We can do what's called cross-multiplying. Cross-multiplying is actually the word we only use that word when we're actually multiplying across an equal sign. So that means we get 12 minus y. We'll multiply all of that by x minus 16. That's going to equal negative xy. Okay. If we expand this out here, we're going to get 12x minus xy plus whatever 16 times 12 is. I should better do that in my head, but I'll go to my calculator instead. 192. Sorry, that's minus 192. Plus 16y. And that all equals negative xy. Hopefully you can see what we want to do is put the y's on one side and x's on the other side. So if I start moving the x's and the numbers to the other side, if I add xy to that side, it's going to become 0. If I add that to the other side, it's 192, and that becomes negative 12x. I'm not actually adding stuff to the other side. I'm I'm taking things away from the same side. But anyway, so that's going to end up with 16y equals negative 12x plus 192. And when I divide everything through by 16, I'm going to get negative 12 over 16, which is negative 3/4, x plus 12 as my expression for y in terms of x. It's a plus. Cool, so what I can do now is I can go back to the original equation, which was the area is x times y. I can replace that y with negative 3/4 x plus 12. And when you expand that out, you get negative 3/4 x squared plus 12x. Okay, or what they've got, which is 12x minus 3/4 x squared. It's the same thing. It's just moving it around. I just realised for part one there might be a faster way to do it, maybe, which would be to take the whole massive triangle that is at 16, 0 down there and 0, 12 there, and work out the gradient of the whole thing. So the gradient of the whole thing would be 12 over negative 16, because 12 minus 0 is 12, and 0 minus 16 is negative 16. So straight away you get the gradient as being negative 3/4 x. And because you know that that line cuts the y-axis at 12, you would straight away have the equation of that line as y equals negative 3/4 x plus 12. Okay, so that's a much faster way. I mean, we still have to put that back into the a equals xy equation. It's a much faster way, though, of finding the equation of that line to put back into here to make that all in terms of x. So that's a faster way. So there you go. And I haven't looked at the schedule yet, but that probably is the way that's in the schedule. But my way works as well, and maybe you've learned another method that maybe could work. For example, let's say the 2 points they gave you didn't sit on the x and the y axes, and you had to do a similar type of problem. Well, then my method may help you with the other one, may not. So I don't know. Anyway, I just looked at the schedule now, and they use the equation of the line, but they also talk about this thing called similar triangles. And so I just want to show you that, just in case you weren't sure what that meant. Similar triangles are where you've got triangles with shapes that share all the same properties, but one is an enlargement of the other one. And I just want to make a quick note about that, just in case it comes up somewhere else. So basically, this smaller triangle is a similar triangle to this bigger triangle. What that means is that they have the same angles. So those angles there would be the same size. So if that was called theta, that would also be theta there. And whatever the sides are, it will be a scale factor to go between it. So for example, if this was 12 and this was 24, whatever this width is, this would be 2a. It would be double it. So the scale factor would be 2, but the angles would stay the same. So that could be useful for other questions, knowing what similar triangles are. Okay, and on to part 2. So hopefully this part is getting easier and easier as we go. So we want to find the stationary value of A. So we know that the area equation now, thanks to part 1, is all in terms of x, which is 12x minus 3/4 x squared. Stationary values are when the gradient is 0. Okay, so dA dx in this case is 12 minus 6/4 x. Okay, and we differentiate it because we want to find out when the gradient is 0, and we differentiate, we get what's called the gradient function. So now if we set that gradient function equal to 0 and then rearrange that, we're going to get 8 as our answer in terms of the value for where the stationary value is. We have to make sure we find what the value of the area is. So we go back to our area equation and we substitute in 8 every time we see an x. Like that. And we end up with an area of 48. Okay, so we've done two things that we need to. We've found the x value, which is 8. We've used that to find the area, which is 48. But we have to remember to do the last thing, which is determine its nature. And to determine the nature of our stationary values, we take the second derivative. So d squared a over dx squared. And when we derive that, we get negative 6 quarters. That's less than 0. That means that it's a maximum point. If you're still struggling to remember why, when it's less than 0, it's a maximum, the way I remember it, I don't know why this works, but if you think of a negative parabola has a maximum point. And so when the gradient's negative, it's like a negative parabola, in which case it's a maximum point that it must be.